Welcome to another Advanced Manufacturing Media webinar. We're glad you could join us for this presentation of AMP for Machine Performance Evaluation and Improvement. The goal of this webinar is to show you how to leverage AMP. That, by the way, stands for Analyze My Performance, to give it its full name. AMP is Cinemeric's machine data acquisition solution. With AMP, you can collect downtime statuses and performance data from CNC machines in real time and automatically calculate key performance indicators such as overall equipment effectiveness based upon this data. Hello, I'm Jim Sawyer, Executive Editor of Manufacturing Engineering Magazine, which is part of the Society of Manufacturing Engineers Advanced Manufacturing Media. Before we begin, I'd like to provide some background on what we will be doing today. Our sponsor is Siemens Industry Incorporated, which provides CNCs and motor drives, as well as industrial design and manufacturing software and retrofit services, application engineering, training, and more. This webinar is intended to provide attendees with a strong understanding of how AMP provides the highest degree of transparency over CNC machine utilization in order to allow you to maximize performance across the entire shop floor. During the presentation, you will be able to ask questions using the Q&A box that appears at the right of your screen. Time permitting, your questions will be answered following the presentation. If time runs out before we can get to all the questions, we will make sure the answers are emailed to you. Portions of this webinar will include screen sharing. As often happens over the Internet, the quality of the presentation can be affected by the type of Internet connection you have, the total bandwidth available to you, and the number of people accessing that bandwidth at the time. Mobile users will not be able to view the screen sharing, but they will be able to hear the audio portion. An archived version of the webinar, viewable no matter what device you are using, including the screen sharing portion, will be available later today. If you experience any audio or visual difficulty during the live presentation, please let us know via the Q&A app. Also, if you have any questions about any other aspects of our webinars, please email me at jsawyer@sme.org. Now, I'd like to introduce the presenter for this webinar, Luca De Ferrari, Senior Consultant and Solution Architect, HYLASoft North America. Originally from Italy, Luca was one of the first consultants to help open and grow HYLASoft's North American headquarters in 2007. With 2 master's degrees from top computer engineering universities and a strong family background in manufacturing, he started his career at HYLASoft as a manufacturing execution system specialist. In this role, Luca provided full-time consulting services to Siemens to support some of their largest North American IT projects. I will rejoin you after the presentation is complete. But right now, let me turn things over to Luca De Ferrari.
Hello everybody, it's nice to be here today. Thanks for joining this webinar. So I'm going to be the presenter today. And first of all, it's an honor for me to be here today and run this webinar in collaboration with Siemens. What I'm going to do is to briefly introduce my company, HYLASoft, and then deep dive into the product presentation and an actual live demo of the system, analyze my performance. So a few words about HYLASoft. HYLASoft is a global system integrator and a consulting company, which is strongly focused on the needs of the manufacturing industry. Our mission is to provide a creative technology solution that helps manufacturers to be more productive and efficient within different areas. And the areas on which we focus the most are the engineering, so the product life cycle management, the manufacturing execution, which involves machine data acquisition, DNC, tool management, as well as shop floor management, quality control and SPC, and supply chain management. As I said, we are a system integrator, which means that we don't develop our own software. In fact, what we do is to partner with the top software vendors in terms of IT manufacturing software and bring the best solution available to our customer. Siemens is our main partner in this area, and we have a very long time partnership with Siemens for the suite that you're going to see today, as well as their MES and product lifecycle management suites. The headquarters of Islasoft for the Americas is located in Chicago, which is also where I work. That's my location, and we are a global company. So being global allows us to support, obviously, large customer implementation that involve more than one region, as well as smaller customers that have only one plant in different locations. Different location in US, in South America. For example, we have an office in Brazil, in South Africa, and in Australia are also the other location for our offices. We're not focused on a specific industry, but in the past years, lately I've been very focused on the discrete manufacturing. So parts manufacturing, aerospace and defense and automotive are becoming more and more our area of focus. What I'm gonna present today is a suite called the Sinomeric Integrate, which is offered by the Siemens Motion Control Group. Basically, Siemens offers a very comprehensive suite of products, specifically targeted to machine tools. This suite is called Sinomeric Integrate, but it contains many different modules that can be used all together in an integrated fashion, or one by one, depending on the needs. Today, we'll focus on one of these modules, which is called Analyze My Performance, or AMP, which is the MDA solution for machine data acquisition and OE calculation. Some other modules, for example, in the productivity manufacturing set, are Manage My Programs for DNC and Manage My Tools for physical tool management at shop floor level. So the Sinomeric Integrate modules typically sit at level 3 of the ISO 95 standard. In fact, what the suite aims to do is to bridge the gap between the enterprise resource planning level, so ERP, and the shop floor, which is the level 2. In fact, it can be used to automate the processes between level 2 and level 4. For example, feeding ERP system or scheduling system with real-time information extracted directly from the machine tools, as well as from presetter, tool storage system, and any other device that can be utilized at shop floor level. Analyze My Performance is the focus for today. AMP, or Analyze My Performance, is the machine data acquisition solution by Siemens. It allows to retrieve machine data in real time and then calculate specific key performance indicators such as the overall equipment effectiveness, the utilization, mean time between failure, and so on and so forth. The suite, as you will see during the demo, comes with a comprehensive list of out-of-the-box KPIs that are automatically calculated on the fly based on data collected from the machine. Why is it important to monitor it and to monitor these KPIs? So obviously, if you don't have accurate data related to productivity and machine performance, you will not be able to know if you can improve. So typically, when we visit customers across the United States, we see that their overall equipment effectiveness is around 60%. But if you look at world-class OE, manufacturer should be, or at least they should have the target to reach at least 85% of OE. So the message is that there is room for improvement everywhere, but if you don't start to monitor what are your performances today, you very hardly get to your target. And that's the main goal of Analyze My Performance. It will provide the means to monitor your performances and a bunch of different other KPIs, set your targets, and allow for continuous improvements. Other important aspects of A&P is that, especially to the plant manager or to the business, it will give you the means to, for example, know why you're not producing as expected, how well your machines are performing, how well you are doing maintenance, or what are the most frequent technical failures and why they are happening, and much more. And we will see some of these questions that A&P will allow to answer during the demo that I will show you later on. In terms of the features, so performance enhancing for sure is one of the main features that A&P provides, but also it provides a lot of different dashboards that allow companies to analyze performances and KPIs, and also allows for scalability. In fact, you can use it as a standalone solution, but also as a client-server solution to integrate more than one machine. So how does it work? Just to simplify how to use A&P, we can summarize its utilization in three main steps. One is the acquisition of the machine data, and this is done by having the client components of A&P installed on machine controllers or on devices that constantly collect the data out of the machines and the devices and send this data to a central server in order to be stored. The server, what it will do, it will take this data, it will aggregate it and calculate the KPIs on the fly and expose this KPI into very nice graphs, bar charts, Gantt charts, and many other different visualization charts that can be used by supervisor managers to evaluate the overall performance of the plants. So we talk about KPIs. These are some of the KPIs that the tools allow to calculate, and obviously they are calculated on the fly. The machine utilization, it's a very important indicator, and it tells how much time the machine has been producing over the scheduling time. So this is one of the indicators, and the second one is the availability, which is also one of the factors to calculate OE. Availability is the actual time that the machine could have been producing over the scheduled time. The performance, it's another important KPI, part of OE calculation as well, which basically tells me the actual speed of the machine over the target speed of the machine. Finally, the quality, which is the third and last component of the OE indicator, it tells me the number of good parts that I've produced over the total produced parts. OE, as I said, is a combination of availability, performance, and quality. And then there are a couple of other KPIs that I would like to mention, which are very important for you to understand how well you're doing maintenance. And one is the MTBF, mean time between failure, which basically tells you the average time between two faults, as well as the mean time to repair, which tells the average duration of faults. So in the first case, in the mean time between failure, obviously we want to maximize this value, while for the mean time to repair, we want to minimize this value. We'll see all these KPIs during the live presentation. So some companies are not ready for OE calculation. Maybe they just want to do downtime status monitoring and analyzing the codes for downtimes. So obviously it is possible to configure A&P the way it's needed. So if some KPIs are not of your interest today, and you want just to use Analyze My Performance to do downtime status monitor, that's obviously be possible. And it will be the first step towards the OE calculation. So here there are reported the formula for the standard OE, and you can see availability times performance times quality in percentage, but also an entry-level OE, which is just based on the availability of the machine. So some of the things that we will see during the demo are listed here. We will show the overview of the machine data, so how to monitor the data coming from the machine in real time. We will show all the different dashboards that are available to managers to evaluate the performances on the floor. We will show how to navigate this dashboard and to filter in real time based on the information that we actually want to see. How to do root cause analysis of potential problems, navigate the different status of the machines, how to set the factory calendar based on when you're planning to produce, when you're planning to do maintenance, and so on. And as well as the plant overview screen, which basically gives you at a glance a real-time overview of all your machine in your shop floor, their status, how well they are producing, and how many good parts, bad parts they've been producing so far. So I'm not going to spend too much time explaining each one of these dashboards, but this is just to introduce what you will see during the demo. You will see dashboard related to machine availability analysis, machine fault reasons, machine statuses in real time, historical condition analysis. Obviously, besides looking what's happening right now in real time, you are also allowed to go back in time, maybe and do a comparison of the performances of your equipment in the past 10 months, for example, and see if there have been months where you had particular challenges, and even drill down to a single week, to a single day, or to a single specified time frame on which you want to perform the analysis. So we will see all of this. And the same for the part counts and CLRs that could be interested to do the analysis. I mentioned before that there are two possibilities in terms of architecture for AMP. One is a standalone solution, and the second one is the client-server solution. In our experience working with customers in US, most of the times customers are interested in client-server solution because the main difference between these two solutions is that in the standalone you have an AMP installation on a single machine, which is separated from other installation on the other machine. So you will not have a shared repository of data, but one repository of data for each machine on which you're running the software, which basically wouldn't allow you to do comparison between machines. It wouldn't allow to do analysis on group of machines. So it can be utilized maybe for only one machine, but if you're looking for a scalable solution and looking to integrate more than one machine in your plant, the client-server solution is the one that definitely would fit this type of need. And the way it works is very simple. There is a small software application that has to be installed on the controller or on a PC next to the controller, depending if it's a Sinomeric machine, if it's a Fanuc, if it's a Heidenhain, and so on and so forth, which constantly collects data and sends this data to the central server. The central server will store the data in a SQL Server database and calculate all the KPIs that are needed for analysis and expose this information into the available dashboards. The good thing about AMP and what it makes it unique, in my opinion, is its capability to integrate information from multiple machines, from different vendors, and no matter how new, how old they are. So AMP really is not a solution that is targeted only for job shops that have 840D controllers from Siemens, but also to companies that have multiple different controllers, multiple different machines that they want to integrate in a single platform like AMP. As a matter of fact, AMP can extract data from 840D controller as well as Fanuc, as well as Heidenhain, as well as Mazak. So it really doesn't matter what type of controller or machine you have on the shop floor. Ilosoft, with the usage of AMP, can extract this information and give it ready to calculate the KPIs that are needed. Even for very old machines that maybe don't even have a controller, or if they're too old, it's very hard to be integrated. We have solutions that basically allow us to use input-output devices connected to the sensors on the machine and extract this information and give it to AMP for KPI calculation. Now, after this brief presentation, I would like to show you AMP in action. So we go through the actual demo of the tool. So I'm going to share my screen now in 1 minute. And what you will see during this presentation, it will be I have a simulation of a controller, a machine controller, on one screen, and on another screen I will have the AMP software running. So you should see my screen in a second, I hope. Okay. So this is the AMP dashboard that I'm going to show you, but first I want to show you the controller that we're using to simulate data from a machine. So this is a simulator for an 840D controller, and the current status of the machine is in production. So we are actually producing parts right now. Back to the AMP screen. Here are all the dashboards that are available that I briefly mentioned before. You can see, for example, the status history, the history of availability, rate of utilization, the status analysis, and so on. And you can see that the same graphs that I have, the same dashboard that I have available here, are also available with a different icon here on the right. We're going to see only the one on the left, because the one on the right basically are the same graph but allow to group by a certain number of machines. So for example, if you have some machines that are joined in a cell, in a concept of cell in your plant, and you want to see the performances of a group of machines, you would use the graphs here on the right. In this demo, I will just show the graph related to one only machine. So let's start from status history. By default is set to the 24th and 25th of August. Obviously, this is all configurable and it's all filterable. So you can see a lot of filters here. You can filter by your machine that you have on that you want to see the data. You can filter by the period, for example, the current time frame or day, week, month, year. You can even specify the time frame you're interested in. For example, let's choose the period as a day, and let's focus on some days starting from the 12th up to today. I just click on the green arrow here, and in less than a second you can see that I have all the information about the status of my machine grouped by day. So for example, on Wednesday, August the 12th, I can see that my machine has been in running state here in green for 70% of the time, which was 16 hours and 49 minutes. I can see that the machine had a technical malfunction for 2 hours and 33 hours. Sorry, 2 hours and 33 minutes. And then there has been also some downtime for organizational reason and downtime without organizational reason or technical disturbances. These are just status that we define for this demo. Obviously, they can be defined based on your needs. So it can be any type of status category you would like to see on your floor. This is just an example. What do these status mean? Downtime for organizational reason is, for example, time that maybe your operators had to attend meetings or training, so they could not actually be running the machine. While the downtime without technical or organizational reason are, for example, those downtimes which involve cleaning, maintenance, measurement, tool change, and so on and so forth. Again, this is just an example. Within these status categories, obviously there can be sub-statuses, and we'll see some examples more in details in a few minutes. But for example, you can have status under production, for example, that can be production override between 50 and 70, for example, based on the speed of your production. And underneath the downtime without technical or organizational reason, there could be, as I was mentioning, cleaning, maintenance, tool change, and anything else we would like to add. Concerning the statuses here, you can see these statuses may be a combination of automatic and manual statuses. Automatic statuses, it means that AMP has collected the statuses directly from the machines without manual intervention. So this is what AMP is getting from the machine. However, it's also possible to have manual statuses. So sometimes controllers are not able to provide the real status of the machine or maybe the real cause for a downtime in an automatic fashion. So the operator working on the machine can actually, in the controller, directly in the controller, declare the cause of a downtime or declare a manual status. And then, based on this declaration, AMP will do its calculation and will expose the data here. In terms of filtering, I show how we can filter by day. I'm going to just give you an example also how to filter by week. So there have been 3 weeks since the 10th of August till the 30th, and this is the aggregation by week. So you could see here that, for example, the week of the 17th, our production was actually very good. We had the 97% of the time spent for actual production. While if you go back on the week of the 10th, we had 80%, almost 80% of production, but we had 7 hours and 20 minutes of technical malfunction, which, may lead us to think that there has been a problem which we may want to prevent in the future. Let's move now to another interesting graph, which is availability versus utilization. Again, here it's aggregated by week, but we can focus on any time frame we want. So I'm gonna just pick the same time frame we used before, from the 12th up to today. Okay, and here you have a quick overview of your availability and your utilization day by day. These KPIs are very important because basically they allow me to see at a glance how well I was producing in the specific days I selected. And what do they mean? You can see in this graph that sometimes I have high availability and high utilization, which is perfect, ideal situation. But also sometimes I may have high availability and low utilization, or low availability and equal utilization. So what does it mean? For example, when I have high availability and low utilization, makes me think that it was not a machine problem. It was maybe a problem with operators that were not actually utilizing the machine as expected, because obviously if my machine was available, so it means that it could have been produced parts, but if the utilization is low, why, even if my machine was available and could produce parts, the utilization was low? So maybe operators did not perform well that day. I don't know, maybe the production plan was not done in the proper way and we couldn't exploit the full capacity of my plant. These are all questions that a graph like this would help you to respond, because it gives you the means to do accurate analysis of poor utilization across the days. Another situation in this graph is not present, in the simulation is not present, but if you have very low availability and low utilization, it may mean in this case that the machine have had problems. So maybe it's not a problem operators not performing well, but it was a problem with the machine. So maybe I had too long technical failures that had my machine been down for like hours and hours, which gave me a very poor availability rate. For example, if we focus on the 25th, which is today, we can maybe start from this graph and see what's a typical analysis path that a manager may perform when he sees this data. So we can see here that the availability is 95% today and 80% of utilization. So let's drill down into these KPIs and see what it actually happened. So one of the possibility after I see this value is that I go and take a look at the previous graph for the today's time frame. So I just go back here and I focus on the current date. And I can start from, for example, maybe when my shift started, so 8:30, up to the end of the day, be fine. And in this stacked bar chart, I can see that I've been producing for 52% of the time, but I have 35 minutes of technical malfunction. And 1 hour and 29 minutes a downtime without technical or organizational reason. So if I want to further drill down and see what were the sub-statuses for the non-productive time, I can do that with the next graph. So I click on Disturbance Cause Analysis. And here I have each status that you were seeing in the previous graph, same time frame by default, but with all the sub-statuses. So, for example, for the technical malfunction, which was 11% of my time, I can see that 4.21% of this time, it was time allocated to solve the technical malfunction, while the 6.87% of the time was the time waiting for a resolution. And this timing will contribute to calculate the maintenance KPI that I'll show you later, mean time between failure, mean time to repair. As well, I can have a quick overview on the other status categories of how much time I spent for cleaning, how much time I spent for maintenance, waiting for spare parts, setup, and manual tune change. Here on the right, I think you notice that there is also the frequency of the specific downtime status category or sub-status. And I can see, for example, that the technical malfunction, I had 2, which basically is the combination 1 status waiting to be solved, and 1 status is problem currently under resolution. So this is the frequency of each status. Now I can move, again, based on the data that I have for today, I can move and have a further look into my status Gantt chart. This is real time. You may notice that this line here is progressing as I speak. And these are all the status that we have been on today. So let me pick a good time frame so that I can show you better values here. Instead of doing until midnight, I may want to do it maybe up to 15. It's close to our time. And I can also maybe put a different zoom, which gives me a very nice overview of the machine status based on the hour. So you can see down here the hours starting from 8:30, and I can see, hour by hour, minute by minute, the status of my machine. So you can see here production almost until, not really until 9, but close to 9, and then I started having some downtime due to setup, due to maintenance, due to waiting for spare parts, manual tune change, and so on and so forth. With the red bars, obviously, I may be concerned because it tells me that there has been a technical malfunction. And in fact, as you can see here, between almost 10:30 to 11:30, I had a technical malfunction here. Now, what I'm going to show you, just to prove you that this is real-time information, is a change of status. So I'm going to, right now we're in production. It's around 3:45. I'm going back to the controller, and I'm going to simulate different status. So here you see the controller. I simulate, for example, setup status. I wait for the controller to go in setup status. Okay. And I go back to my machine. And in a few seconds, you should see a small bar coming up under the setup. See? So if I stay in this status, this bar is gonna progress towards the right as all the other bars. Okay, the last two things that I would like to show you are the counter of time graph, which is based on the part counts. And here it shows basically the percentage of good, scrap, and rework that I did for the current period. So I can obviously also in this graph go back in time and see statistics about the counters. This is something that gives an idea about your quality factor. So obviously if you had a lot of scrap, it means that your quality for that day was not very good, and therefore you will see in the OE trend that also the OE, the overall equipment effectiveness, is going to be affected by this. And the other graph, which is very important, is the KPI graph. The KPI graph here is going between the 12th of August up to now, shows the trend of different key performance indicators that we selected. So the OE indicator, the quality, the performance, the utilization, and the availability. So at a glance, you can see your OE in red. In this case, it was very high, 200%, which is obviously not realistic. But why was that? Because we made a simulation on those days between the 14th and the 18th of having the machine running over performance. So if the target speed of the machine was, I don't know, 10 pieces per minute, for example, we were running right above that in the simulation that we have. And in fact, the performance was very high, and as well, the OE was following the trend of the performance factor. If we want to see more realistic values, for example, we can simply focus on the last 2 days where we were running more realistic data. And here you can see that the OE indicator has been low, 20%, mainly because the performance was low and also the quality was not ideal. Consider that in order to have 80% of OE, availability, quality, and performance should be higher than 90%. So as soon as one of the three factors is low, the OE is very impacted. But at least you can see that values are below 100%, which is definitely more realistic. The other two KPIs that I can show you are the one related to maintenance, mean time to repair, mean time between failure. These are for the past 2 days, and you basically can see that today, on the 25th, we have around 14,000 seconds for the mean time between failure. Obviously, this can be minutes, in hours, the way you prefer to show it, and allow less than 2,000 seconds for mean time to repair. So it was very low, the time to repair, which is good. It was high at the time between failure, which is also good. All this information can also be seen in tabular form and exported in Excel if needed. And the time frame, again, it can be specified based on your needs. In terms of dashboard and evaluation screen, that's all I wanted to show you for today. There will be much more, but we don't have the time. I just want to mention that also all the MC alarms coming from the controller can be captured by AMP and be reported in this logbook. So these are all the NC alarms coming from the simulation, and in this case there were communication to the PMC failed, but there can be much more. And last but not least, I want to show you another overview screen that typically is used by plant operators, plant supervisor, or even managers in their office to have a quick overview of all their machines in the shop floor. This image down here is just an example. You can put the layout of your plant, any type of image you like, and then on top of it, you basically you have these intelligent blocks which are connected to your machines, and which color and statistics are updated in real time. For example, this is the machine that we've been focusing so far. It's in setup mode. If you recall, I set the setup mode a few minutes ago. And in fact, if I go back and I set it back to production, immediately the person using the plant overview screen will see the color changing. You see here it's less than a second. You will know in real time the status of your machine, information about good parts produced, scrap, rework, the status, and many other. You can also put the KPIs here. It's really configurable as needed. Very last thing I would like to show you is the work calendar. And here is where you schedule it's not a scheduling system, but it basically allows to define when you are supposed to produce, how many shifts you have, if there is some time that has to be allocated for maintenance. This can also be integrated with an actual scheduling system that you may already be using at your plant. And based on the information defined in this works calendar, the OE KPIs are calculated accordingly. So for example, the availability KPI is telling me for how long my machine could have been produced over the total scheduled time. The total scheduled time is defined in this window here. All right, so that was pretty much it for the live demo. I hope you enjoyed. I think we have 6 minutes left for question and answer, so we may want to go through different questions.
Hi, Luca. Thank you very much. I have the feeling that there is a lot more that could be learned about AMP, and I'm sure that many of our audience would be interested in staying around to learn about it. But we do have some questions, and for the audience, if you would like to stay on, we do not have a really hard stop at 3 o'clock, so we will continue past that point if necessary, but not to an unreasonable length. So to come to our questions. Number one, Luca, can AMP be used to collect data from non-cinemeric controllers, and are there any limitations when they do so?
Yes, absolutely. As I was mentioning, AMP, one of the benefits of AMP is that it's able to collect data from non-cinemeric controllers like Fanuc, Heidenhain, many others. The only limitation is that there is no installation on the actual controller. So on A4EDs, the AMP client, the data collector, will run directly on the controller, while for non-cinemeric, PC next to the machine is needed. But in terms of data that could be collected, there are no limitations basically. It's just it cannot run directly and be installed directly on the controller of the machine. A PC is needed. That's the only limitation.
All right. And here's something even a little more specific. Can Allen Bradley PLC-driven machines be connected as well?
Absolutely, yes. It doesn't really matter what PLC is hooked up to the machine. AMP is able to collect data out of Siemens S5, S7, as well as Allen Bradley PLC. And the communication is not done only via PLC. Getting data directly from the PLC is a possibility. Sometimes OEMs, they do not provide access to the PLC, so they are locked. So we have different options to collect data from this machine, which can be communicating directly with the controller. It can be MT Connect. It can be Fanuc Focus if we're talking about Fanuc controllers. It can be TNC Remo for Heidenhain. Can be via OPC. So many different possibilities. And Allen Bradley definitely can be integrated as long as the OEM doesn't lock the PLC.
The next question considers rework, and our listener asks, is it calculated the same as scrap? At his operation, it is usually assumed that rework is all scrap in terms of calculating OEE.
Correct. The rework typically is defined by the operators working on the machine. As far as the OE calculation is concerned, only the good and the scrap will be used for the calculation.
Okay. Next, can AMP draw alarms and/or errors from the machines and include those in the failure analysis?
Yes, this is possible in the alarms graph alarms table that I was showing before. All the alarms and NC alarms coming from the machines can be stored into the AMP database and be browsable by the user of AMP.
All right. A very good question here. Can AMP be customized regarding the data being analyzed and how it is reported?
Yes, and the word that I would use is configured more than customized, because typically customized involves some custom development, which we tend not to do. We tend to stick to the standard configuration options that the software provides. And also in this sense, AMP is very powerful because all the screens that you have seen, all the status models, all the KPIs, and all the different screens in general can be configured as the customer wants. What we typically do when we engage with this type of implementation is to analyze what are the requirements of the customer and the way the customer would like to see the data exposed, and then based on those requirements, we configure AMP accordingly to meet those requirements.
All right. How does AMP know about the production schedule?
It basically knows about the production schedule in the works calendar, which is the last window that I show you. There you can define the production plan, when you will be producing parts, for how long, when there will be maintenance, if there is a planned downtime, if there are holidays. And based on this work calendar, he will calculate the KPIs accordingly.
All right. This listener asks or notes that during the demo, I saw that the performance KPI was not at 100%, and he wants to know why.
Yeah. So the simulation that we are running for the controller from which we are collecting data is simulating parts being produced at a certain speed. So during our test and during our demo preparation effort, we simulated some speed of the machine, which was not 100% realistic. So we were going much higher. We were producing many more parts than what the target for the machine was. So accordingly, the performance was very high values, more than 100%, just because we were doing more than what we were expecting to do. So that's why it was higher. In the past 2 days of simulation, we were running below the actual target speed of the machine. Therefore, the performance was at reasonable levels.
All right, I understand. Can AMP be interfaced to a scheduling system?
Yes, it can. Obviously, it depends on the integration capabilities of the scheduling system in use. Siemens has a very nice scheduling system, for example, that potentially can be integrated. But obviously, if customers have different scheduling systems, those may be integrated as well. And typically, we perform an analysis first to understand what are the integration capabilities, if these are scheduling systems that we have never dealt with. In other cases, if we already have experience in that type of integration, we will just leverage on that, and probably an analysis would not even be needed. So it really depends on the system, but generally speaking, yes, it can be integrated.
All right. We will take one last question here before we wrap things up, and that is, can the status hierarchy and names be configured within the tool?
Yes, as I was showing, we just picked some names for the status categories and substatuses that we just made up for the sake of the demo. For example, you may recall the downtime for organizational reason. Obviously, it can be even more specific. It can be, downtime for technical malfunction, and underneath that we can have, hydraulic failure, mechanical failure, electric failure, and so on and so forth. So that's one of the other things that we do in collaboration with the customer. During the analysis phase, we understand what is their status model, the type and name of the statuses that they would like to see in the dashboard, and then configure the tool accordingly.
Luca, thank you very much. Unfortunately, our time is up. For those of you who would like, Luca's contact information is here on the screen in front of you. and you can get in touch with him by phone or email. And for those questions that were not answered, we will pass them along to Siemens and to Luca, and you can expect a reply via email. This entire webinar will also be available for replay shortly after 4 p.m. Eastern Time today, and you can access it by using the same sign-in link you used earlier. You can also provide that sign-in link to your colleagues who might be interested in learning about AMP as well. And speaking of learning, Luca taught us that the interaction of software and CNC machines may be complex, but it can be used to do more than just calculate toolpaths. In fact, this interaction is becoming a key component of manufacturing today. SME and Advanced Manufacturing Media have a host of ways to help you keep in touch with the latest developments in manufacturing. For instance, the August issue of Manufacturing Engineering covers innovations in machine controls as well as multifunction machine tools. The September issue will take a look at manufacturing software, PLM in particular, and our October issue will contain our annual software supplement. In addition, upcoming SME events allow you to look at and learn about the latest in manufacturing techniques and technologies. These events include WestTech, September 15th through 17th in Los Angeles, and the Canadian Manufacturing and Technology Show, CMTS, September 28th through October 1st in Mississauga, Ontario. I'd like to thank you for joining us for this Advanced Manufacturing Media webinar today, and we hope you found it informative.